Hello everyone, thank you very much for watching this live lesson. This is lesson number 9 from the Java Fundamentals stream, and here we discuss about arrays at the moment. Now it will be a very long lesson full of details that you need to know for that OCP exams. Unfortunately, even though they are fundamental and even though they are not necessarily very used in real life situations, all of the details that you will see here and maybe also in the future lessons are really needed for your OCP 11 exam. So make sure that you know all of them before going to the exam. That's why I will show you in examples all of the needed details that you have to know before you attempt that OCP 11 exam. And I will just start with the examples. After, I will take the opportunity to remind you that if you are watching the event live, you have a live chat there and you can send questions via the live chat. And of course, if you are watching it recorded, or if you are simply if you simply have a question afterwards, you can always use the comments section as well as the discussion section on the channel, or you can follow me on LinkedIn and Twitter and you can ask me questions there, and I will make you separate videos to respond to your question, or simply I will just reply to your answer to your questions in the next in the next event, in the next lesson. So of course, I would also like to remind you that you can subscribe to the channel and you can share the channel with other folks that you know they might be interested. So let's just go on with the first example of this lesson, and we were discussing about arrays. So first of all, what are these structures that we call arrays? They are simply, by definition, called a collection of variables of a final, so constant number, and always of the same type. So that's why, for example, when we will discuss about creating an instance of an array, they are objects as well, so we just consider them as any other objects. They will have instances, and each instance can have its own attributes, and one of the attributes is the length. We always choose from the beginning which is the type. And for example, we can choose a primitive type, like for example int, char, float, double, the 8 primitive types that we have discussed in the previous lessons, or we can choose an object type as well, and we can even have arrays of arrays. That's the last part of the arrays chapter that we will discuss, if not at the end of this lesson, maybe in the next lesson. So important to know from now is that we always choose the type, and that will be the type that all the variables of the array have. If you define an array, you actually define a collection of variables, so more variables altogether, and they always, all of them have the same type. And the syntax is type followed by these brackets, and then it will be a name of an identifier that you have to choose, that has to respect the same rules of the identifiers that we have discussed and used until now for all the variables, for all the variable definitions. So for example, you can choose x, and this would be the definition of a variable that can store a reference of an instance of the type array. So then inside this variable you can simply assign, by using the equals operator, the same way you were assigning different type of values for primitive variables or references when you would instantiate a normal object with the new and the constructor. Now you can use the equal operator to assign the reference to an instance of an array. And because it's an object, we will use the operator new, same as we are doing for objects in general. And then we have to use the type of the array. That would be, in my case, int, because it has to be the same as the one I defined for the declaration of the variable. So I can't use another type of an array. When I define the needed variable, I also specify the type, and then I have to use the definition of an array of the same type. and then I come again with the brackets here, and I have to specify a length, and this length that has to be 0 or positive, always an integer type, is constant. That means that for this definition, for this instance that I have created here, I cannot change the length anymore. So I can always, for example, come and reassign the reference by creating a new instance of the array. So I can create another array using again the new operator, and then I can choose another length, for example, but I cannot change the length of an array that I have once created. So I can just recreate another instance and reassign the reference in the same variable. We already know that I can do this only as long as I haven't declared the variable as being final. This is something that we have discussed in the previous lesson. And assuming that this really is a variable and it's not constant and I can reassign values, I can do indeed that. I can simply recreate another array and reassign another reference to the same variable, but that doesn't mean I have changed the length of the array. It only means I have created another array with a different length. That's important to know, that the length of the array is constant. You can't change the length of the array, so the number of variables inside the array, once you have defined the array. So let's just come back to our first declaration when we have just given the definition of an instance with 5 variables. So how does this look like? We can just imagine that this is a simple array having 5 variables inside, like a string of variables of the same type, in this case of type int, and you have 1, 2, 3, 4, 5 variables, and always each of them is indexed by using an integer starting from 0 and consecutive. So it will be 0 for the first one, and then 1 for the second variable, 2, 3, and 4. So always in this case, the value of the index for the last variable, important to know, it is the length minus 1. So 4 in this case, because we were starting from 0. So you can simply imagine that these are variables, and x is all this structure here containing the 5 variables. The length is the number of variables that will be contained. And then each of the variables are represented by its index, and that's the way you can refer to one of the variables. You will always refer by using the index of that position you want to work with. So it will be by the name of the array and the index of the variable inside the array that you want to use. This is the basic, this is the fundamental. In case I would have created an array with length 10, of course, then I would have had 10 variables, and then the indexes in that case would have been from 0 to 9. Again, 9 because it's 10 minus 1. So always last index, to know from the beginning, last index is equal to length. So in my case, x is the name I have given through the identifier to the variable containing the reference of the array. Then I can refer by the dot operator, which is the differentiation, length to the length of the array, and this attribute is always containing the length of the specific array. So in my case, if x was defined by having the length of 5, this is a constant that will always have the value of 5. So the last index of any array will always be length minus 1. That's because we are starting the counting from 0. Pretty easy until now, but it's only in a comment because I only wanted to explain you that you can actually declare this, and this is the way it looks like, and then you can use these variables here, for example, to add some values. Let's just do that. So in order to show in the first code example, let's just really create an array and then really assign these values to these variables and then print them out. So let's see how can we do something like this. And I will just take it exactly as I have explained it. I can declare an X and then I can just assign the instance of an array. I have to choose my length here, that will be 5, and we can do that by declaration of the variable and then instantiation, but you will see me in a lot of cases just doing that on the same line, same as we can do with any other declaration of the variable. We can just do an initialization syntax, and that means that you declare and assign a value at the same time, and this is also possible with the arrays. So you can do that on the same line like this, or you can do that with two instructions as I have shown in the comment above. And then you can simply refer to any of the variables by using again the brackets, and inside the brackets you should have the index of the variable to which you refer. So for example, if I want to assign value 8 to the variable indexed by the position 0, I have to write something like this, that will be on the left side of the equal operator I have x of 0, and that means the variable inside x that is referred by index 0, and then I do the operation of assignment, that is assign value 8 to that variable. And of course I can do that with all the variables in my array, so I just assign value 9 for example, as in my example above, for the position 1, and then I can assign value 7 for the position 2, and then I can assign value 1 for the position 3, and for the last position, that again is length minus 1, which is 4, I can assign value 2, and this will simply create exactly this structure here that you see, where I just have created an array of length 5, so of 5 variables, and then I assign a value to each of the indexes specified, and the last index that I can access is 4. Now we will see later in one example that if you would try to access an index that is either negative, so smaller than 0, or more than the last index that is length minus 1, that will throw you an exception, and I didn't discuss yet about exceptions because that's one of the future lessons, but I will show you for the moment, and then I will just complete the explanation in the specific lesson where we discuss about exceptions. Here will be an exception that is named array index out of bounds. So array index out of bounds exception is that exception. You can keep it in mind. We will come to it later, and I will explain what exceptions are in details in a next in a future lesson. And then you will actually have to know for the first exam for the OCP 11 certification, you have to know exceptions, and you have to know also some of the common exceptions, the most encountered of the exceptions, like array index out of bounds exception is one of them, and there are others as well, like index out of bounds exception, null pointer exception, arithmetic exception. There are some classes that I will discuss in more details. So for the moment, just keep it in mind. This is what happens if you either try to access a negative index or an index that is greater than the last index of your array, and the last index of your array is always length minus 1. So this is how things are working. And now, knowing that the indexes are always starting from 0 and are always consecutive, you can imagine yourself now that you can use a repetitive control structure to parse this array, which is pretty easy. And maybe the best that you can choose here is the for control structure that we have discussed in one of the previous lessons. And you know that the for control structure has 3 parts separated by the column operator, and in the first part you have to declare a variable that will be used inside the control structure. And we can, for example, declare a variable in this case that represents the index. So I want an I that will start from value 0 because this is the first value of the array. So that's what I want to declare here. I will do on the same line the declaration, the assignment. You know from previous lessons that you can do the declarations before. That's another story. If you want details on that, I would go back to the last lesson. So if you have missed that, or you still have troubles, or you don't understand these syntaxes, they were explained in a previous lesson. If it's still unclear after you see the previous lessons where I explained that, please don't hesitate to send me questions and ask me about details, and I will provide them to you to make sure that you understand everything on this. Now I will continue assuming that you know these things. So I start from 1, and then I will go until the length of the array. So that will be x in my case, and then length. That is oh sorry, it was semicolon here, not column. And that's what I'm doing is I'm declaring starting from 0. I've said 0 being the first index, and then I'm going with that with until length, but without length. That's not an equal here, so it's not smaller than equal, it's only smaller than. So the last value that this I will actually have is length minus 1, and the reason for that is because I really want to go up to length minus 1, which is actually the last of the indexes, so I don't want to go to the length. And then I simply can use the plus plus operator to increment each time I do one of the set of the operations. So you know that the order of execution for a for is first of all the assignment of the first part, and then we have the second part checked, which is the condition, and is always of the type boolean. If that is true, the block of instructions between the curly braces will be executed, and then the last part. So I will first be 0, and then will become 1, 2, 3, 4, and then it stops. And so I will simply, by this control structure that I have written here, I will simply parse all the indexes of this array. So now I can just system out print, for example, x of I, and being that I have here values starting with 0 and up to 4, then I will simply print in the console the values in the variables x of 0, x of 1, x of 2, x of 3, and x of 4. So I just simply print on each line of the console the values inside all the variables of my array. So this should be easy to understand, and let's run the example and see what happens in the console here. I should have started by showing you that I have already created a project using version 12, but you might already know this because we are doing so for already 8 lessons. You see that exactly the values that I have assigned here are now in the console, so they were printed out on separate lines. So how did this work? We simply can just add here a debugging breakpoint, and then just start this with debug and see it line by line. Again, we will see that we just assign in our array, we declare the array, then we assign in all of the variables, we will assign the values 8, 9, 7, 1, and 2. You see that in the beginning the values of the variables inside the array, all of them contain 0. So the reason for that is because the variables inside are all of them of type int, and they are considered to be kind of attributes to the array instance. And the default value for an attribute of type int is 0. I will again come back to this detail later, but for the moment you can keep in mind that these variables of the array will always have the default values of the attributes. That's because they actually are attributes of this instance. So in this case, being int, the default values are 0, 0, 0, and 0, and then they will be overridden. So first of one became 8 because of my assignment above, and then the second one will become 9, the third one will become 7, the fourth one will become 1, and the last one will become 2. So that's how it now looks like. It's just containing the values similar to the way I have represented them here in the above comment. And now by using this for control structure, declaring an I starting from 0, which is the first index, and going up to length minus 1, length is 5, but being that I use here the smaller than, so I don't use a smaller than equal, 5 will not be reached, so 4 will be the last value that I will have before the condition becomes false and the control structure will end. So if you just go now line by line, you will see that first of all 8 will be printed because it's x of 0, so I is now 0. You can see its value if you go above it with the cursor. So it's 0 now, so this is x of 0, and x of 0 is 8. So this is what we will see in the console here. 8 will be printed, and then the same will happen for the second one, which is 9, and then 7, and then 1, and then 2. And this is where it's ending now, because I will get the value 5. So after getting the value 5, it will not be smaller than 5 anymore, and then it will simply exit the control structure. So you have seen I was 4, then it was I++ was executed, I became 5, 5 smaller than 5 is false, so it just exited, and it's now at the end of the program. So that's why my program here is simply printing the values that I have assigned. I hope this example was clear. I want to go now into a little bit more details about the declarations of the arrays. So what I want to discuss with you now is what happens with the declaration of the variable, which are the possibilities, and what happens with the actually instantiation of the array. What are here our possibilities again, and you will see there are a lot of syntaxes again. I don't want to discourage you, but there are a lot of syntaxes and you have to know all of them. That's why this lesson and the next one we will see a lot of syntaxes about arrays and how they are declared, and you have to know which are the correct ones and which of them cause compilation errors, because in the exam, in the OCP 11 exam, you will actually have situations in which you have compilation errors and you have to just discover them by looking on the lines of code. You will not have a debugger anymore and you will not have an IDE anymore. You just have to see them black on white and understand the code very well. But by all these examples that we will do together here, I really hope that they will cover all the situations that you can find in the actual exam. So let's go and create another class that will be example number 2. And inside example number 2, where I will actually create again the PSVM public static void main method, I want to discuss more about the instantiation. So instances, how can you declare the instance of the arrays, which are possible syntaxes and which are the differences between the syntaxes. So you can simply consider that I have declared an X that is like the one you have seen in example 1, but let's see what other possibilities of creating arrays do we actually have. So the first of them was the one that you have already seen, where I have simply assigned an instance, and you have seen that by default this instance has those 5 variables of type int, all of them, and then I just came one by one, and using the indexes I have referred to each of the variables, and then I have assigned different values to them. Now if I go, I can simply use another kind of declaration, but you have to be really careful where you actually do that. It has to be an initialization itself, so you can't use it when you simply do an assignment if the variable was already declared. You have to use a declaration itself. So we just will create here an Y, and instead of assigning an instance that is created by using the new operator and then the type and the brackets with the length that I have presented above. When you do an initialization, you can, if you have the values already, you can directly use these curly braces in between which you can simply specify which are the default values. So this is an empty array here. It has the length 0, but you can declare one in which you from the beginning specify values. That would be, for example, let's choose some values. So in this case, I have by default created an array of length 5, and all the values that I have placed here and I have separated by comma, I already have them in the array. And if I would come with a for control structure and parse this array and print the values in the console, you would see these values. So the array was directly initialized with these values. So you have to keep in mind this way of declaring arrays, but also keep in mind that this can only be used when you do initialization syntax. So the declaration and the assignment of the array have to be on the same line. You can't do something like this the way I have done here with X. You know that the syntax where the new and then the array of declaration is done can be done with declaration and then assignment, but you can do it as well as I have shown in the previous example as initialization. Well, this is not possible when you have this kind of a syntax. This can only be used in initialization syntaxes, and you will find these situations in your questions if you attend the OCP exam. The OCP 11 exam, you have to know that if you see a situation in it which this syntax is used, but not in an initialization, but in a declaration and assignment like this, it will simply cause a compilation error. No matter of the situation, it will cause a compilation error. So you have to know that. Good. That's the second possibility that you have. Now you have a third possibility. You can mix them together and do both of them, which will allow you more possibilities. So for example, I could simply, let's call it W here and W1 actually, and then I will say something like this. We'll mix them together, and then you will find out that I can actually do an assignment to a variable using this kind of direct initialization with values, but I can do that not by the syntax that I have shown you above. This is only possible to be done when you do an initialization. I can do something like this only if I write the type before, but always make sure that here you never specify in this situation the length. So this is the most common mistake that you will see in the exam questions for this kind of syntaxes, for this kind of assignment. You will see that in some questions the length is specified here, like in the case of a normal initialization, but you can see if you do something like this, even if the length is the correct one, like you see here that I have really specified 3 values. It doesn't matter, the syntax is wrong, your code won't compile in this case. So make sure that if you use this kind of assignment where you specify both the type and the values, then you shouldn't specify here the length. Of course, automatically an array of length 3 will be created, and you don't have to do anything about it. Just by specifying the values, like here, automatically an array of the given length, of the needed length, will be created. But you don't have to specify the length here. You only specify the length when you simply create an empty array, and then you expect afterwards to add the values as we have done in the first example. But if you do it like this with the curly braces, then you can either choose to do an initialization, and then you can simply just specify the curly braces, and you can as well add the values if you need, and automatically an array of the needed length will be created. So if you don't specify any value, it will be an array of length 0, and if you specify values, then it will be an array of the length of as many values you have added there and separated by comma. And that can be only in an initialization syntax, but if you want to separate them but at the same time use default values for your array, you can do that with a combination of the two syntaxes, but be very careful so that you don't specify here the length. That's really important. I found that a lot of times in the questions for the OCP exam, so it will be probably in yours as well. Good, and that's part of it. Coming back now, you remember that we have discussed about the var word, which is part of the language starting with version 10, and being that you will probably want to attend OCP 11, which is at this time of recording the video and the live event, the last certification version, so being the last term supported version of Java is also the last version for the certification. You will probably want to attend that one, and then you have to know what happens with the var word as well. So a little detail has to be known about the var word together with arrays, and I want to cover it now. When you use the var word, first of all, var replaces completely the type. So if you specify something like this, you simply can go and declare your array, and you will never see here brackets. I also had this question from one of the followers, and one of you guys who are watching these videos, thank you very much for that, and for your attention to them. The question was, can we use, why don't we use the brackets here when declaring a syntax like this with the var word? And the answer is because the var word simply replaces the type completely, and these brackets here are considered to be part of the type, so you can see them all together as being the type here of the variable, even though I will come to more details and you will see that this can be placed also after the identifier. Still, when you use var simply replaces completely the type, so it's just a replacer for the type, that being only in a local initialization syntax where the type will be automatically taken from the value that you assign in the right side of the equals operator. So for this for this, it will know that this variable here is of a type of an array just because in the right side of the equal operator I have specified an array. So automatically this variable will become of the type array of int. You don't have to specify the brackets because var replaces both the brackets and the type of the variables inside, because this is actually the type of the array and var replaces completely the type of the variable. This is the first thing you have to know. The second thing you have to know is that you can't use the var word with this kind of initialization that I have shown you here with the y variables. This cannot be used with var. So if you try to do something like this, where you just assign by the usage of the curly braces, no matter if you use empty braces or you just specify values, again, doesn't matter, you won't be able to do that. This syntax is not allowed here, as well as it's not allowed with the declaration and assignment. So you can't use something like this. I will simply comment it out and say not possible. But if you want to use the var word and as well give some values default to your array, you can do this by using again this syntax here that I have shown you a little bit earlier. So where you mix the first with the second type of assignment all together, but you don't specify the length. This can be used with the var word as well, and let's try it out here to see that this is really possible. So again, I won't specify the length, but then I will just be with the curly braces, and then I can specify my values, and automatically this will create an array of length 4 because these many values I have added in my array. And you see that I was able to use the var word as well. So again, you will probably, and my opinion would be, and my advice for you would be, that you should always attempt the last exam version, the last version of the certification. So that being version 11 here, you have to know the details about var word as well. I have given some details previously about var word, and I will just give them some more on the way to our end of the course. This is really important, these two syntaxes, to be known by you before attempting the OCP 11 exam, because you should expect to find these syntaxes in the OCP 11. And one other thing that we should know is that you would need to know when you can use the array as a parameter to a method, and that is, in my case, I can simply create another method, and I will just create a private static void m, I can call it, method here. And don't mind about this static. I know that we only did cover the static keyword for variables, and we didn't use it for methods yet. It will come in some of the next chapters. For the moment, this is just a normal declaration of a method, and you can just avoid taking into consideration this static for the moment. I have placed it here because, as you will see, from a static method like main, I would not be able to call without an object method that is non-static. So in my case, like I do here, for example. And let's assume, and this is what I want you to focus on, let's assume that I have here a parameter of type array. And yes, this is possible, and again, yes, this is exactly what you have seen here for so many lessons already. This is an array, and then you just have to, if you have the array here, you just have to use the variable that you have. And I see a question: hi, how do you pass a var as a parameter? I'm not really sure that I understand the question, so I will try multiple answers. First of all, if it's only about the value itself here, you can see exactly that I'm doing that. So you see that I declared here a variable using the var word, and this is of type array, and then I have a method here that receives as a parameter the type array, so I can simply pass it as a parameter. If the question was, however, how can I use var as a parameter? Like, for example, would I be able to declare a parameter of type var like this? If this was the question, then the answer is no, you can't do that. The syntax of var can only be used inside of a block of code, so something like this is not possible. You can't use the var word as a parameter here, and you can't use it also you can't use it as a return type. This is not possible, and you can only use it inside a block of code. You can never use it, for example, for attributes, so some definitions directly inside the class var x. This is not possible. You can't do something like this. So I hope this is what answers to your question. You can't have var as the definition for a parameter, but you can simply declare anytime a variable using var inside, as long as it is an initialization syntax, like you see in this case. And then if you have a method that receives an array as a parameter, don't forget that the actual type of Q1 is taken from the value assigned in the right side. So the value on the right side here is array of int, so it matches exactly the type of the parameter here, array of int. Then I can simply pass that variable to the method as of for any other variable. Super. Now this is one important thing. The other important thing, now you know how to pass the value, but the other important thing is to know what you can exactly write here. You can always write the name of the variable. Doesn't matter if it is declared with var or some other way. For example, it would be the same, easy to just replace it with w1, and the reason is that's still an array of type int, so that can be used because it matches correctly the type of the attribute. And you can as well, if you want, directly use this syntax, so you can simply pass directly the definition of the instance to the method. But you can never, and this is again important to be remembered, you can never use here the syntax with the curly braces directly. As you can see, if I would try to write something like this, this is causing a compilation error. So this, again, I will place it in a comment and say not possible. You can, however, again, mix those two syntaxes, as you have seen here in a lot of my previous examples already, and this is correct. So if you really want to directly pass an initialized array, you can do that by using the syntax that also specified the type and the new operator before. And again, be very careful. You don't have to, you shouldn't define here the length, otherwise it would be a compilation error, and you will see in a lot of exam questions this situation, and you should spot it very fast. If you see something like this is a compilation error, you can answer pretty quickly to that question. I know a lot of examples here, and maybe they look to be so much not really important. And of course, if you are even a senior developer, you might have skipped seeing a lot of this kind of syntaxes until now, because it's not something that you see a lot in a real life scenario. So in general, in real life scenarios, in real life applications, life is much easier. You won't see, for example, more than this kind of declaration of the array, and you used the same we have done in example 1. So this is pretty much what you see in a real life scenario. But when you go and if your target is to obtain that OCP certification, you have to pass the OCP exam, you really need to know all these details, which maybe they are not really practical. Maybe you won't find them in a real life scenario a lot, but you have to know them, otherwise you will miss questions in the exam, and your target is to miss as a few questions as possible. So if possible, answer correctly to all the questions. So this is the syntaxes of the instantiation of the array that you need to know. And now we would have to see in example 3 the possibilities that you have for the left side. We have already discussed about the var word, but we have more possibilities in the left side for the declaration of the array. So let's see what happens there in a next and the third example here. Example 3 would be this one. So if I want to declare variable of type x that would be possible to be used to store the reference of an array, we have seen that we can do it like this, and you will see that it's actually possible to place the value as well, not x1, it can't be the same name, x2, but you can place it after the identifier. So in a lot of situations, and you will see that a space is here between the type and the brackets are not important, as well as here they are not really important. The important thing here is that you will see situation in which the type will be before the identifiers, but also the type, that means the brackets for array, will be specified after the identifier. And the question is there a difference between these two kind of declarations? Moreover, you will see that this is possible to be done also in the parameters. So in case I want to declare my main method using the brackets after the identifier, this is still correct. This is still the main method and it works the same, and it doesn't make any difference if I place them just after the type or just after the name of the parameter here. It still means the same thing. And the answer about the difference is actually that if you have only one of the definitions of the variables per instruction, so like this, it doesn't make any difference if you place it before or after. But the difference comes if you have multiple declarations at the same time. So guess what happens, for example here, if you specify like Z1 and Z2 on the same line, and you know this is possible. You know from the first lessons that you can declare multiple variables with the same instruction by providing separate identifiers and separating them with a comma, and this is possible with arrays as well. So in this case, what is actually Z1 and what is actually Z2? Well, both of them will actually inherit the type that is before the declaration, so immediately after the type, and that means that both of them are actually arrays here, so are references of type array. That means that you can use Z1 here to declare to store the reference of a declaration of an instance of an array. Same you can do here with Z2. You can store the reference of an array there. But if I would have specified the brackets after, then I could get into a situation that is similar but not the same, and that would be something like this. You see here that instead of writing the brackets immediately after the type, I have written them after the identifier, but I have only written them after W1. W2 here in my case, it is actually a primitive of type int, because what's not immediately before the type is not inherited by all of the variables declared. So in my case, W1 will be an array of variables of type int, while W2 is actually only a primitive. So to W1, you can use this variable to assign an array if you want. But for W2, you can only assign a primitive, because this is only of type int. So this became of type int, while this became of type array of int. So this is the difference when you use the brackets after the identifier. They are only inherited by that identifier and not by all of them. If you use them immediately after the type, then all of the variables, like in this case, will inherit that bracket, so it will in this case become arrays. That can even extend. We didn't discuss yet about having multiple dimensions like matrices, arrays of arrays, thing that we will just discuss in the next lesson. But to give you some before, to give you some spoiler about it, if you would write something like this, so just A1 and A2, then here what you can spot is that you have the situation in which you have both of the declarations. In one of the case, you have also specified the brackets immediately after the type, but for one of the variables, you also do that after the identifier itself, but not necessarily for the second one. So what actually happens here is that what is immediately after the type is inherited by both of the variables, and that means that A1 and A2 will both of them inherit the fact that this is an array. But then everything that is naturally placed after each of them will be obtained only by that specific variable. So what does that mean? Well, it actually means that A1 is what we will call in the next lesson a matrix. It is an array or of arrays. So its definition would actually be something like this. But A2 is only a normal array. And the reason for that is because A2 only inherits one set of brackets, that is this one, that will be actually inherited by all the variables that are separated by comma and declared on the same instruction. So A1 inherited what's immediately after the type and added what was declared specifically for it, while A2 doesn't have anything specifically for it, so only inherited what is immediately after the type. That's why here A1 has 2 dimensions, which means it's an array of arrays, and this is what we will discuss in more detail in the next lesson. And this is why here in the declaration of the instance I had to specify 2 pairs of brackets with 2 different dimensions, lengths, and that's what we will discuss in the future. And in case of A2 I only had to specify one set with the length, so what we have done even until now. And the reason is because actually this is only an array, so it has only one dimension, the one that was inherited from here. That is going to you will actually see in some questions of the exam cases like this, and they can look a lot strange, because you can see the declaration with only one variable, and you see something like having one variable and the brackets are both before and after, and you might think that this is wrong, this is not compiling, but this is actually compiling, and it's working very well, and it's working based on this syntax that we have discussed here. So the reason for why I show you all these things is that I want you to know what is compiling and what's not compiling, and how do they work when you will face them in the questions for your OCP 11 exam. So make sure that you know that this is possible and what does that actually mean. And as I've told you, in case you have only one declaration of one variable, then it doesn't matter. This is really equivalent to have placed them, both of them before, or both of them could have been placed immediately after the identifier, or as you have seen, one of them can be after the type, and then you can add as many as you want after the identifier, and they just sum up for the variable itself. And yes, this becomes different, in case I add here another variable, and that's what I have explained here with the A1, A2 examples. So this is something that might look strange, but you have to know them. This is why if you here in the main method just place the brackets before the name of the parameter, or after, it simply still makes sense, and it compiles, and it even works, and it's the same main method. It's important, again, this is another topic of the OCP 11 exam that I have to repeat it, and I want to repeat it to make sure that you remind it. It is really important in Java how you write the main method. In some other languages it's not important, and you might see in specific languages like C, for example, that you can have a main method returning an int or a main method returning a void, and they both are the main method. But in Java it doesn't work like that. If it doesn't have this syntax, is very possible that it will be not understood as the main method. So for example, in Java you can't simply replace void by int and still be the main method. You can't just use here a capital M in main and it's still working. This is not working anymore. This is not the main method anymore for Java, and this will just give you an error when you run the program with Java. It can't be to be non-static, and again we will discuss what static is. It can't be non-public, and there are very few changes that you can actually do in the main method such that it still is the main method. So one of the things that you will see is that you can just use static and public in the other order, and this will work because the order of the modifiers in Java is not relevant, is not important. And this is something that I have discussed also in the previous lesson when discussing the static for variables, and I have said the same for static and final. You can use them in either order and they will work. So for the modifiers, public is a modifier, we will call it an access modifier and discuss it in more details later. Static is a modifier as well, and being that these are modifiers, you can put them in either order. And again, one of the changes that you have seen that we can do now in this chapter is that you can actually declare the main method by using the brackets afterwards, and this is still the main method and it works fine, and it will be recognized as the main method by Java. And you will even see, still in this chapter but in the next lesson, because our time is almost up here, that you can use this syntax that we call varargs, and varargs are very close to arrays, and that's why we will simply discuss them just in the next lesson. And you will see how these varargs are related to the arrays. This is still the main method. In some cases, some of the hipsters like to use this kind of declaration. I don't know why it doesn't make any difference to just use the normal brackets, but you can do that. And if you want that what varargs are, you can simply declare the main method and use the vararg syntax, which is these 3 points I will describe into more details in the next lesson. And this is as I've said, related to the arrays as well. So I don't want to go into more details for the moment. I have covered half of the things that we will discuss, that we have to discuss for this arrays chapter. So we still have some syntaxes that we need to do, including the arrays of arrays and the varargs syntax. They will be part of the next lesson. For the moment, I will leave you with these examples here, and just make sure that you know how to declare arrays, all the things that you can write on the right side and when can you write them of the equal operator, all the situations including the var word starting with Java 10 that you can use when declaring arrays. So the correct syntax is of how you declare the variables that can store references of arrays and when can you use them, how to refer to a variable inside an array, what happens if you try to use an index that is either equal or bigger, greater than the length, or smaller than 0. It throws an array index out of bounds exception. Again, exceptions will be covered in more details in one of the next lessons. And how can you simply parse an array, the easiest way being just with what we have learned, the standard for loop, that is just by having an index, parsing the indexes from the first value, which will always be 0, and to the last value, which will always be length -1, and then you can refer to that variable. And for example, in this case, I have simply printed out in the console. Again, one of the things that we have to discuss in this chapter is the enhanced for loop, and that's a different for loop that you will see. It has only 2 parts and they are separated by this column here, and then you will see a syntax that is used usually to parse arrays. It looks like this, and then this local declaration here will just take the values from the collection that you have in the right side. But I will just describe this in more details in the next lesson. I don't want to do that now because we have no more time for that. Okay, if you don't have any other questions, thank you for all the questions you have asked until now. If you don't have others, then I suggest closing this lesson here. And thank you again for your participation, and I hope it was again useful for you, this lesson as well. I hope to see you soon in the next for the next lessons as well. So stay tuned for the next live events that I will schedule soon. And in the next lesson we will continue with the arrays with all the syntaxes that just remained to be discussed. Until then, see you soon and bye bye.